Are the third session of Lightning Talks. We have an hour today, I believe, correct? So we also have the quilt, which has me in stitches. Sorry. Started already. So the first person that we're going to have give a lightning talk today is Scott Sanderson. Scott Sanderson here. Awesome, there we are. And then up on deck, we have Harish Gupta. Harsh? Yep, you're good. You're here. Okay, great. Awesome. And yeah, great.
No. Okay, good. Let's see. Maybe. Oh, I see something. There we go. Cool. I'm going to scroll that out slightly. Cool. So the title of this talk is Code Transformer, an AST-like module for bytecode transformation. But I'm going to warn you in advance that the subtitle of this talk is Unspeakably Evil Hacks in Service of Marginally Improved Syntax. So this is a project that came out of sort of a challenge that I gave to a coworker of mine where we were doing a bunch of projects with AST transformation. So Python actually has a built-in module in the standard library that lets you get the AST of Python code and then muck with it in various interesting ways. But there's some downsides to that. So for example, you have to have access to the actual Python string source, which you might not have if you only have a .pyc. And there's a couple things that you actually can't do nicely with that. So we wrote a library that lets you do something like this. So here, I just have a function that returns dictionary, and I'm going to decorate it with this decorator called ordered_dict literals. And if I call that, it's going to return me an order dict instead of a regular dict. I can also do things like this. So in normal Python, if you have an except block, you can only match your exception on exception types. You can't do instances. But if I decorate my function with pattern-matched exceptions, then I can do except value error of bar, return bar, except value error of foo, and then the value error, or the actual exception block that I enter is going to get matched on the arguments I pass to the exception, not just the type. And so if I call that, I actually get foo and not bar. So how does this work? So in CPython, at least, when you run a function, what the CPython compiler actually does is generate bytecode. And there's a standard library module called dis that you can actually use to inspect this. So my function foo there actually gets compiled into literally like a byte string, and I can get a nice sort of human readable representation. But the actual implementation, or the actual format that Python has this in is like a very short byte string. And so you can see it's doing a build map and a load const and a load const and a store map. And then if you look at the decorated version of my function, make that slightly smaller, sorry. You can see that I've basically entirely rewritten the bytecode of that function. So how would you actually write something like this in practice? So say I've got a function like this. I'm making some NumPy arrays and doing some math on them. And the disassembly for that looks like this. So I'm going to load some globals, load some costs, call functions on them. Basically, I'm just loading things onto a stack, calling functions. The output of those functions end up back on top of the stack. And the end result of this is I get a NumPy array. One of the challenges with NumPy, as probably a lot of you know, is that for expressions like this, you end up creating and throwing away a lot of temporary arrays. And so there's a library called numexpr that lets you sort of pass in your evaluation string all at once, and it'll sort of more intelligently deal with things like temporary arrays or constant folding for you. So this will do the exact same thing. But now it's kind of annoying if I want to be doing NumPy type things, or I want to be doing things with numexpr. I have calls to evaluate all over the place. And wouldn't it be nice if I could do sort of like pseudo macros? So here's a code transformer that implements basically crappy macros in Python, in pure Python. And what it does is it says every time I see a load const instruction in the bytecode, look at the value that's being loaded for that load const. If it's a bytes, and this is Python 3, so you have to explicitly have it be a bytes literal, like prefixed with B, then if it's not a bytes, just yield the instruction. Otherwise, emit two entirely different instructions. So what I'm going to instead do is yield or emit a load const of a function that this class is passed in. And then I'm going to load const the string, and then I'm going to call my function. So instead of actually emitting the bytecode string that I would have loaded, I'm going to emit the result of calling an arbitrary function on that bytecode. And so now if I do at bytestring macros of evaluate here, then instead of having to write evaluate, I can just write a bytes literal here. And it ends up giving me the same thing as I had before. So there's pros and cons. Just like I said, the subtitle of this is Unspeakably Evil Hacks and sort of maybe kind of better syntax. But there are some cool things about this. It teaches you how CPython actually works. It does have some advantages over other metaprogramming challenges, like the fact that you don't need access to the source code. There's some potential optimization opportunities. Essentially, if you take this to this logical extreme, you end up with numba. Right? Numba is essentially taking the bytecode of Python instructions, throwing it away entirely, and just giving you LLVM.
And you'll have to explain the cons later. Thank you.
There are no cons.
There are no cons. All right. All right. And up next on deck is Jackie Kazil. So are you in the room? If you could come up and sit up here or something. Okay. No? If she's not here, get set up if you can. Come on. And then, all right, so we'll skip Jackie if she's not around, and we'll go on to Krishna Sridhar. You in the room? Yep, all right, great. Deja vu all over again.
Yeah.
There we go. Great.
Hello. So I'm here to talk about what's new with SciPy solvers. First about me, I'm Harsh Gupta. I'm a SciPy developer and I'm undergrad at IIT Kharagpur. So yeah, so SciPy had got an equation solver, which, so first I'll initialize the session. Okay, yeah, wait. Yeah, so SciPy has got an equation solver, so you can see here's a linear equation, and the old solver returns a list of solutions. If it has got two solutions, so it will give two equations, and you must recognize this equation as the general quadratic equation. So it uses the quadratic formula and gives the equation its gives the result in symbolic form. Yeah, so it can also solve transcendental equations. So I'm giving very basic examples so that you can see if it is doing the right thing. Yeah, so this is exponential of x equal to 0. Exponential of x equal to 1. Yeah, so it gives the answer 0. So it is exponential of x equal to 1. And yes, but the answer is SciPy. Okay, and this is because of the famous Euler formula, the e to the power x equal to sin x plus cos x plus I sin x, and this means there are infinitely many solutions. Okay, and it is giving one of the complex solution. And yeah, so I mean, and earlier it gave only one real solution here. Okay. Yeah, so I mean, it doesn't return all the solutions. This is the old solver, and this can lead to strange situations like this. So if I try to solve this equation, it is just the previous equation by x, and the solution was 0, so 0 is not a solution because it's not in the domain. Okay, so yeah, it returns an empty list. But does it mean there are no solutions? I don't know. I mean, yeah, so for example, if you're trying to solve sin x equal to 1, it just returns pi by 2. But yeah, we all know sine is periodic and there are infinitely many solutions. Okay, so, and there are few other keywords. So you're trying to solve an impossible equation, say 1 equal to 0, it returns an empty list. If you are trying to solve things like x equal to x, which is true for all x, it also returns an empty list. Okay, so I mean, I'm just giving the bad parts of the old solvers there. Like, it's pretty powerful. So yeah. So like last year for my Google Summer of Code, I wrote a new solve set module which returns equations as set. So yeah, initialize it, and so and there were also you saw that like for the exponential equation you were expecting at for e to the power x minus 1 it gives 0, and for e to the power x plus 1 it gives pi, and you weren't really expecting to give it to give complex solutions. So we broke the real solvers into complex solvers so that it's things are much clearer. So here's the complex solver. If you tried, so this this equation has got no solution, so it returns an empty set. If there are all solutions, it returns the real number line. For the complex number, it returns the complex plane. And yes, so for real e to the power x minus 1, it just returns 0, which is the only solution. And it can also represent infinitely many solutions from the solves. Yeah, so we have got image set modules so that we can represent infinitely many solutions. So here we do it. And yeah, so.
And thank you for solving all of our problems.
Thank you.
All right, next up on deck is Michael Sarahan. Are you around? You're here? Okay, great, thanks. Yeah, you're not. Sorry, when I say next up on deck, I mean that you're in the wings here, and you should be accessible, just to go over the rules again. Right. Did we lose the...
No. Okay. So today I'm Krishna, I'm from Dado, and today I'm going to be showing you something fun about how we integrate C++ code with Python. Pretty simple and clean. So we have this thing called an SDK which you can download, and you just include 2 header files. One's called toolkit function macros in flexible type. Is the font big enough? Okay, is that better? Oh, I actually don't know how to do that. It might be. Color map, is it? Any Vim users here? Okay, let's just roll with it. I don't actually know how to. I think it's set PG dark. Yay! So, okay. So here I'm going to define the simple function that says multiply by 2. It takes in a double and returns a double. And I have a function here called add. It uses this thing called a flexible type. Just think of it as a Python any type. Works on anything, strings, integers, lists, dictionaries, recursive types. You can even do images actually with it. So here I'm defining add, which is a plus b. All the plus operators are overloaded to do the same things that you do in Python. And then you define a couple macros that says multiply by 2 with the argument b and add with the arguments a and b. And I just do make on this code. And I'm going to switch to an IPython notebook, which is not rendering correctly, is it? Oh, jeez. What's wrong? Ooh, okay. Ooh, what's going on? Okay, for now, so then all I need to do is it makes a .so file. And now I can say import example1. And it says example1.multiply by 2, 10, and I get back 20. And then say example1.add 2, 1, I get back 3. I can actually do this with strings as well, and I get back what's needed, which is 2, 1. And I can do the same thing with classes and things like that. There's all sorts of fancy stuff. And why we really do this is because we want to do run native C++ code sometimes in loops or something. So here I'm going to load, this is called an S frame, which is basically a data frame. And I'm going to apply this C++ function on it. So it does a logical filter, and then it applies the C++ function on it, and it does it all in parallel because everything's written native in C++. So with this, you can pretty cleanly integrate any C++ code with your Python code. That's it.
Thank you so much. DWF, you around? Ah, great. So you're up here next.
Take this out first.
Okay, yes.
And then.
Order of operations matters.
Yes, sir. So, did you have any audio at all?
No, no audio, thanks. Is there a light there? Nope.
Mirror display.
So,
Mirror display.
sorry guys, this may be out.
So, how do you bring up your display settings?
David, you want to come up and I'll do my display settings and see if I can get this going?
Okay.
We got a Mac, so he's on the other
Let's
one.
try this. Don't go here real quick. Let's try this.
That's the wrong one.
Oh, I see.
This is a mini HDMI.
Okay, yeah, sure.
So many standards.
Oh, I have HDMI actually. Oh, you do?
Yeah.
Plug that in first. Plug it up there. Okay. Where is it? All right. So, where'd my mouse go? Oh, there we go. Anyone know how to mirror displays? Yeah, all right. And I should probably know this, but view, present. All right. Hi, everybody. I'm David Ward Farley, or DWF, or simply Dwarf, if you prefer. I'm from Montreal, and I like writing software, but deep learning is my main bag. And so I'm here to talk to you about Theano and some other stuff built on top of it, or aside from it. So Theano is, for those who haven't heard of it, it's a math expression compiler that's been developed since about 2008. It's heavily integrated with NumPy. Similar to, if you saw the Dask talk, similar idea, more actual compilation of things. The main audience is deep learning researchers, so for prototyping and things like that. And you've got nice features like symbolic differentiation and graph transformations for speed and numerical stability. And that's the core team, notably absent myself. These are the people who you have to thank or blame, depending on the situation. And they do a fantastic job, however. And so recent news, the thing that I'm most excited about, partly because I was involved in it, is that we no longer have a 2 to 3 build step for Python 3. There is a single code base, meaning you can run the bleeding edge version right from a Git clone, which is kind of important because this is a fast-moving library. So yeah, this made me cry tears of joy when it finally got merged. Other things that are less recent, cuDNN support from NVIDIA. You can do convolutions with FFTs now. There's a new backend, and if you want to do really, really fast stuff, you can do half-precision floating point, things like that, and improvements for recurrent nets. There are a lot of, there's actually a whole ecosystem of tools built on top of Theano now. And there were a couple built at Mila that had various strengths and drawbacks. I was involved in PyLearn 2 for a long time. These were really the things we wanted out of a library. We wanted, minimal additional cognitive overhead, so that you didn't have to know much beyond Theano, because Theano was already kind of hard to learn. You wanted well-defined interfaces so you can extend things, and you wanted sort of everybody to be on equal footing as far as the research people were doing. And one big thing, which is harder than it sounds, is job resumption, and serialization to disk and being able to resume a job once you've I don't know, figured out your job scheduler, or put out the fire on the cluster or whatever. What has happened since is something called blocks, which was started by Bart up there on the slide, along with Dimitri, and yeah, we're getting to be like the Mats at SciPy with Dimitri's in Montreal. They're like 3 now, and hopefully more soon. Yeah, job resumption was baked in from the beginning, and lots of fun things that you can do for managing graphs Theano graphs you've already created, and we're really serious about software engineering. So we spun off the dataset parts of blocks as a separate library with a lot of neat features. We want to do sort of multi-process stuff where you read and pre-process in one process, and then go on with your learning in another process. We plan to integrate this to PyLearn 2 at some point. We also, in the process, use Pickle. We dropped Dill mainly because it was too slow for our needs. Really, the only thing that we needed was iter tools to be pickleable on Python 2, and sometimes the best way to do things like that is just to re-implement them. So that's out there. So I'll leave you with the thought that just because you build tools for doing research doesn't mean your tools should be research quality code. There's a bunch of URLs up there, and my email address at the bottom if you want to chat or just find me.
Couldn't have said it better myself. Thanks, David. All right, Mike, you want to try again? And then next up is Bryan. So.
Thanks.
All right. Okay, guys, so you can thank Alan Downey for this. This presentation, he said, oh, this is a good story, you should tell it. So last year, shortly after SciPy, very depressingly, because I got an IPython sticker and put on my phone and really liked it, My phone was stolen. Now, who am I? I am kind of a material scientist by training. So that there is a STEM, scanning transmission electron microscope. That's kind of what I work on the most. That's an image, if I can get the scroll to work right. So those are atoms, and my research has been a lot of analysis of those atomic scale pictures. So basically, this is all to say, when it comes to data, I don't know squat. Okay, so my phone disappears, and I'm like, oh man, where did this thing go? So show you a different window here. This is my provider here showing my call history from the month of June. You'll notice that there are 3 pages of about 20 calls each. And then if you're doing any kind of profiling of, of when a phone gets stolen, let's see, July 2014. Okay. Never mind, there's 48 pages. Okay, so it's obviously stolen, but now I'm lazy, I'm kind of cheap, I don't want to buy a new phone. So I really say, this is a Sprint-like provider. It's not tied to a SIM card, it's tied to the phone itself. So as they're using my phone, the records are still being logged, right? Which is why I get those 48 pages. So I have all that data. I'm going to do these imports. Here is my data. And I'm going to take a look at really who I should contact. Who are they contacting the most? How should I contact them? Do they call or they SMS the most? Sorry, I'm not friends with trackpads. But SMS is really probably the best way to reach out to this person if I ever get a hold of them. Really, this differs between people. So a lot of people get called, some people get texted more. So you can do that with Pandas pretty well. Just do the group by a little bit differently. And you find out, well, man, that person's getting texted a lot. Who spends the most time talking? Because really, talking to people is the best way to pressure them. They can ignore texts pretty easily. But if you call them, you can do a little bit of more social engineering. Okay, yeah. And so finally, when to contact them. Kind of evening. That's not terribly interesting, but yeah. Okay, so I did that, and the rest of this story is I did end up getting in touch with the person. I was supposed to meet them at a Walgreens. My coworkers very intelligently said, you should call the police and have them escort you to do this. So I did, and the police were there, and there was a really suspicious encounter, but these people ultimately didn't engage with us, so I didn't get my phone back. Thankfully, I've got new Jupiter stickers this year. But all this is to say, I learned some really important stuff. Put a lock on your phone so that any kind of geolocation stuff works when your phone gets stolen. Do cloud backup stuff so you don't lose your photos and stuff. Use a Google Voice number, because I was getting calls at 2 or 3 in the morning for months after this, people looking for this person who had taken my phone, right? Because they think I am that person now. And finally, be safe, and if you're going to do anything shady, get the police involved.
Wow, some great advice. Sounds like an amazing way to meet new friends. Luke C. Campa, you didn't really write legibly, so.
Where did the,
Is there a Luke who's? There we are. Great. Great. And now it's Bryan.
So if your IPython or Jupyter sticker toting phone is lifted, we can give you a new sticker, but not a new phone. So. We live? Fantastic. So I'm Bryan Granger, one of the lead developers of Jupyter and IPython, and I wanted to give you a short update for the past year and also looking forward. So year one of Jupyter. At this meeting last year, we announced Project Jupyter, and for those of you who weren't here, Project Jupyter was started as an evolution of IPython to be a home for the language-independent parts of the architecture. This is the user interfaces, the console, the notebook, the Qt console, as well as the infrastructure for notebook documents. IPython remains as the Python kernel for Project Jupyter, as well as IPython Parallel and the Python implementation of the Jupyter widgets. Today, Project Jupyter supports over 40 programming languages. We're absolutely thrilled about the adoption that's happened over the last year. Yes, I guess this does mean that some people occasionally write code in languages other than Python. What have we done this last year with Jupyter? The main task has been to split the monolithic IPython repo and package into multiple repositories and packages under the new Jupyter GitHub organization, as well as working on splitting the documentation, all of that. And also, as you've hopefully seen, we have designed a logo, stickers, and t-shirts. Looking forward, the 4.0 release, it's coming in the next month. It will primarily be simply a rearrangement of the packaging of the project from a user perspective. There will be some API, command line, and configuration breakage. Project governance, our project is run by a BDFL, Fernando Perez, who couldn't make it this year, in addition to a steering council. We're pleased to announce that in the last year, we have 2 new members of this, Jessica Hamrick, and just this week, Jason Grout. So please stand up, give them a hand for their fantastic contributions. We're also pleased to announce that as of this week, we have a new round of funding for the project. This is $6 million over 3 years from the Helmsley Charitable Trust, the Gordon and Betty Moore Foundation, and the Alfred P. Sloan Foundation. Some of the program managers and various staff from these foundations have been here this week. Let's just give them a great applause. We have a blog post about what we will be tackling with this new round of funding at the URL at the bottom there. What this means is we are hiring, both at Cal Poly, where I am at, and also UC Berkeley. At Cal Poly, 2 full-time software engineers, 1 full-time UI UX designer, project coordinator. Berkeley, 2 postdocs, a project manager, and a half-time admin person. Please come talk to us if you're interested in any of these jobs. Our existing front end, the web notebook that many of you use, yeah, it's great. It's a nice MVP, but it's a pain. It's really a pain to develop with, to add new features to. This makes Jupyter quite upset. We're pleased to announce today a new effort that is a partnership between Project Jupyter, Continuum Analytics, and Bloomberg to build a new notebook, more than just a notebook front end, but basically a new web interface for interactive computing, data science, et cetera. There will be a lot more details coming out over the coming months about this. Some of the different ideas are here, written in the text here. We'll be posting these slides online. And I wanted to show you really briefly one of the different aspects we're trying to build with this. And this is some work that Chris Colbert at Continuum has been doing with a new project called Phosphor. The challenge for many of us is that sometimes we want the notebook, but sometimes we want a text editor and a terminal. How are those laid out on the page? And so one of the things Phosphor provides is a very nice tabbed and paneled layout system that we're going to be transitioning to. And to finish, all of this makes Jupyter happy.
You guys are slaying it on the announcements. That's great. Next up is Stefan.
Thank you. Hey, that was easy. No. All right, so I love Python, almost as much as I love burritos. But one of the things I like best about Python is writing it. And as many of you know, I like my Python to be really fast. And after I write fast Python, I like to share it with my friends so that they will pat me on the back and tell me what a cool dude I am. But there's a problem here. In order to write fast Python, you have to do it in a language that is not Python, which makes it much harder for me to share with my friends. And this has led to a wide ecosystem of solutions that make packaging and distribution easier, which are all fantastic and completely critical to the success of this community. But the underlying problem has not really been addressed by these. Ideally, I would like to be able to optimize my Python code natively without adding any new dependencies. So I'm happy to announce I have a solution. It's maybe not a very good solution in as much as it doesn't actually solve the problem. And it also turns out to have been done before, but it is a really cool solution, and so I'm sharing it with you, my friends. Let me tell you a story. Many years ago, I had a simple task to write in Python. Find the first element in this big NumPy array that is less than 0, and do it fast. And at the time, either there was no simple way to do this, or I was just unable to find it. Maybe it's out there. But regardless, the problem is universal. You have some small kernel of code to speed up. Maybe it's an integration that doesn't vectorize well or something like that. And for me, this was a dead end because the project I was working on had to be very easy to distribute, and that meant no compiled code or new dependencies. This problem is particularly infuriating for me because it's so simple. It can probably be solved in about 15 lines of assembly. That's maybe 200 bytes of machine code. I have all the power of the scientific Python stack at my fingertips, and yet I can't execute 200 bytes of machine code because my chums can't be bothered to install GCC. It's infuriating. It's like, imagine I'm out in the middle of nowhere. I'm barefoot, of course. I'm alone, just me and my car and the prairie dogs. Oh, and it's night. This is totally hypothetical and not in any way related to real events that happened to me personally. So the nearest town is a few hours' drive away, and I'm getting ready to leave, and all the things I require are there. The keys are in the ignition, and the engine is running, and the headlights are on so I can see just fine, but the doors are locked. I'm not sure who did it. Maybe it was the prairie dogs. And I can see through the window my keys and my cell phone and my shoes, and it's like, if I could just get inside, but I can't because I'm an idiot. It's totally hypothetical. Okay, it's a bad analogy, but this got me wondering, functions are just bytes in memories, yeah? And Python can surely write bytes into memory. And maybe if you stuck just the right bytes into just the right memory from Python, you could execute those bytes using C types. Well, it turns out you can do this, and I certainly wasn't the first to do it. On its own, this doesn't really solve anything, but reflect on this. I just wrote and executed machine code from Python without any external dependencies. We really do have access to the underlying metal here, even if it's not convenient. This is like me discovering that the car window was open just a crack. So what would it take? What would it take to make this more useful? Like, first we would need an assembler to generate that machine code. But now we've come full circle because an assembler is yet another unrealistic runtime dependency. Or is it? What if we implemented the assembler in pure Python? That's an interesting possibility. So I did that. It's called Pika. And this is, it's really just a toy project, but it works. And today you can execute inline assembly in pure Python 2 or 3 on Linux, Windows, OS X, 32 and 64-bit Intel architectures. The solution to the find first problem is about 15 lines of assembly. And of course, it's very fast. This is a really fun tool to play with if you want to teach assembly to yourself or others, or if, like me, discovering hidden superpowers of Python sends you into giggling fits. Some people will rightly argue that tools like this are a little bit too difficult to use safely, and maybe they are right. But I sure do like my toys. And the fact that any of this is even remotely possible is one of the many reasons that I love Python.
Remind me not to go camping with you. Awesome. So, Matthias, are you here? Yeah, right there. Right, good. Next.
Okay. Hi, everyone. My name's Stefan van der Walt. So yesterday I watched the Oasis plenary, and I thought, hey, I could tell my life story. And then I realized I would only need a lightning talk for that, so this is perfect. So the last year has been rough for me. I mean, I had a couple of massive transitions in my life. I lived basically my entire life in the small town of Stellenbosch at the southern tip of Africa, and this is where I come from. So you can see, I hope it's bright enough. I grew up with vineyards in my backyard, and I was traumatized by this idea that I had to move halfway around the world to an entirely new place with different features. And so it took me a long time to get ready for this. But then earlier this year, I finally made the transition, and this is where I live now. So that was rough. The second thing I had to do was I worked in this beautiful building, and I couldn't imagine that I would find a job where I would ever have an office like that again. And worked up to it, and finally, like I said, I made the move, and I'm now working here at the Berkeley Institute for Data Science. So this was rough, but my job actually did change quite a bit. I was a lecturer in applied mathematics. I was supposed to teach applied math, publish papers, grade student papers, and perform social outreach. And of course, all the time I was futzing around with Python, to my little credit, often in collaboration with others. Then I took this job at BIDS, and now I've got a much better job description. I get to explore the intersection between scientific domains and computation, push forward the open science source, education, publishing agenda, do research, collaborate, etc. But mainly I'm still futzing around in Python, often in collaboration with others. So, that was quite disruptive in my life. I thought, well, I still have a little bit room to do something else. So one afternoon, I cloned a repository on GitHub, and this led me into a crazy adventure. It was a repository by Katie Huff on how to organize your own wedding. And I cloned the repository, made a few changes. I had 2 names, etc. And then I got a collaborator. And, a few months down the line, we got married. So that happened a few weeks ago. And thank you. So I thought, my year is almost full, but I need something more. So I decided to write a book. So of course, if you want to write a book, you need a cover. So you use the tools and I imported scikit-image. I loaded up a picture of Robbie here. This is my pet lion. Used the O2 thresholding algorithm, got a couple of blobs. That didn't look so good, so I added some noise to the image. This is a useful trick that's called dithering. Thresholded it again, got a very nice version of Robbie there. And scikit-image has a Google of Summer of Code contributor this year. Daniil Pakhomov is working on object recognition. So from scikit-image.future, I imported the object detector that we're building, specified that we're looking for a line, African line, of course. And there you see the result of the line cut out beautifully. So that I pasted onto an O'Reilly cover. And there we have it. So elegant SciPy, I would like to produce to you, to show you this book. That we're going to write in collaboration with Juan Nunes Iglesias and Harriet Dashnow. So now I just need to write the book, and I need to know from you what I should put inside of the book. So we need elegant SciPy code snippets. The snippets must be for NumPy SciPy. It must be applicable to the real world, BSD licensed or public domain. Preferably, you would nominate someone else's code. And the code should be satisfying in some way. Hopefully it would be fast, concise, have broad applicability. In other words, when I see this code, I must hear the heavens open. And that code we will use to bring new people into the SciPy fold and educate them as to how to write code best in this environment. So special request, please give us something for SciPy sparse, SciPy stats, and if you have a good use of SciPy's generic filter, we'd love to see it. Here is the submission URL. All right, and then just a quick 180. Tomorrow we're doing a scikit image sprint. We need your contribution, and whether you're a big picture, small picture person, beginner or pro, you can work on anything from the web to the docs to the bug fixes and do deep tech stuff. Please come and chat to us tomorrow. Thank you.
Thank you, Stefan. Next up is Steven Sylvester. Are you around? Yes. No? Okay, there we are. Great.
Okay, so while I'm trying to set up my computer, I want to say that I'm working a few feet from Stefan, and it's always a pleasure. Okay, so I will be the first, I think, to show a first project which is useless. Everybody who was here before me was showing something useful. Just a few things, a few tips. In current version of IPython, if you're using Python 3, you can use some syntax to basically create Unicode symbols. But it was not really practical because it was only for LaTeX symbols. So now you can do it with pure Unicode. You just type / and the name of the Unicode characters, and you get a gamma, which is really nice because then when you want to have an uppercase A, it's an uppercase alpha for Greek. So it can be annoying to confuse your coworker. And one nice thing you have in Unicode, it's Roman numeral. So this is a 6, character 6, which is like really, really different from a V and an I. And it only works with Python identifiers, and you can set Roman numeral 6. To be equal to 1, which is like a little bit annoying. So what you can do, actually, if you don't want to do that manually, you can just pip install SPQR, which is a small library I created, and now you can just do Roman numeral 6 complete plus Roman numeral, oops, I forgot the backslash, 4, tab complete, and it's 10. Of course, it's still really difficult to type, so you can just import star from here. And I'm really happy to be at SciPy 2015, and you will learn that I'm 29. So you can guess which year we have been born in. Thank you.
All right. Next up, we'll have Sylvan Corley. Are you around? Yes, here. Okay, great. So,
We have HDMI.
do we have the HDMI cable? Yeah, it's coming.
Come on. Here we are. Sort of. Thought about it. Stay this time. I've never seen this happen before. No. Mirror displays. Because it's a retina display. Yeah, I mean, it could be. Is it on mirror image? was going to talk about the construct too. Oh, yeah.
Just do best for VGA this one.
I tried that the first time. Do you have any,
All right, why don't can you come up?
Yeah.
Instead?
Sure.
Okay, and maybe you can
Yeah,
go back
yeah.
and try it again.
how are you getting plugged in here? It's a viewport. I have a VGA. Yeah, I'll do VGA as well. Okay, should I be around? Okay. Almost. Okay. Hi. My name is Sylvan. I'm a quant researcher at Bloomberg and also an adjunct faculty member in Columbia University. And what I do for a living is mathematical modeling for finance, and it's not what I'm going to talk about. So this talk is meant to serve as an enthusiastic praise for the Jupyter Notebook and IPython widgets, and as an empowering tool for researchers and scientists. I think that most of you know this XKCD comics that to me really conveys how simple Python is. So let's have a more concrete example. Let's import gamepad. Here's a gamepad widget. I'm being prompted with a message to plug a gamepad widget. So let's do it. All right, press the button. And now I have a widget for my Xbox controller. Press the button. So it's very easy to use. I think it would be very useful if you have a robot that's hosting an IPython notebook server to control the robot, and for education, for example. So we can easily wire the gamepad with other widgets, such as a slider. But it's not very useful or fun. So let's use more fun widgets, such as flight instruments. So here's a flight altitude widget. Sorry, I forgot to wire it. Okay, here it is. So here's a flight altitude widget and a heading flight instrument that are linked to the values of the different axes. So let's do something a bit more complicated. There is another widget library that was developed by Jason Grout. It's called Py3.js, and it's a wrapper to 3.js that allows WebGL 3D visualization in the IPython notebook. So here's a very simple example of a 3D surface that you may rotate and zoom. It's very fluid, very nice. So what I did is I downloaded some terrain elevation data for the Grand Canyon and plotted this into Py3.js. But the camera is not very well positioned, so what I did is wire the camera with the gamepad. So now we almost have an IPython flight simulator. So I'm not a GIS expert, so I've had to find some other data where I could find a texture and a sky. And here's another example of a mountain in Spain with texture, clouds, and everything. If you find it too difficult to fly with mountains, you may also flatten landscape with a button, and it's much easier to use then, right? That's all.
Amazing. Don't hate the player or the game. All right. We're going to transition. We're going to have Stephen come up again, and in the transition, we'll let Bryan make an announcement.
One other Jupyter-related thing. So after the BOFs today, some of us Jupyter devs and other people are going to go swim at Barton Springs Pool. We invite you to join us and come and talk Python. Thanks.
Cool. And is this? Let's see. I guess while we're waiting, I'd personally like to thank the camera and video crew that's done such an amazing job this conference. So let's all give them a round of applause. I think this year is definitely a record for how quickly the movies are going up. Same day, it's incredible. So, yeah, thanks to them.
Chris Hope.
There we go. Awesome. That's not mirrored though. Perfect. All right, hey everybody, I'm Steve Sylvester. I work at Continuum. Here to talk about some Jupyter kernels that I've written along with Doug Blank. And this page, resize the window, thank you. Okay. So I wrote the Octave kernel because I'd written the Octopi library and wanted a kernel to go along with it using the wrapper kernel interface for kernels. Then I realized I wanted to make one for Scilab. And then I thought, well, this thing is not really the same interaction that you get with a regular kernel. So I asked on the mailing list, and they put me in touch with Doug Blank, who was working on Scheme and processing and other kernels as well. And we decided, let's get together and get a standard set of magics and try to make it easier to write these wrapper kernels. So on the plane, on the way here, I wrote the Exxon SH kernel, the conch kernel for Anthony's library, which I'll demonstrate here. So conch is this weird hybrid of Python and Bash. So I can run Bash, but I can also, Python, I can also run Bash. Well, it's not in this directory. If I had something else. That's why you never run live code. So, and there's completion. Oh, that's nice. Let's see if I can get, oh look, it's a man page. Wow. Let's look at the print function. Oh, all built in the notebook and a standard set of magics. So now these all exist for anything that Doug and I have made called under metakernel that derives from the metakernel, and this Exxon SH kernel was a process metakernel, which we have a contrast problem here, but the process metakernel uses the REPL wrap from the pre-expect with a hack to make it work on Windows, sort of. Unfortunately, conch is one that doesn't work on Windows, but all the other ones I've written do. And look, it's only 77 lines of code to get what you just saw, all those magics, the completion, the help on a conch kernel. So I invite any kernel developers to check that out. It makes your life a lot easier, and it provides a consistent user interface for folks using wrapper kernels. Thanks.
Awesome, that is incredible. So it looks like there will probably be more than 40 languages very, very soon. All right, so this is the end of our lightning talks. Thanks for coming, everybody. Let's give a big round of applause to everybody who came up and gave a lightning talk. Or a rant. Maybe we'll do rants next year. Yeah, so thanks. I think it's now time for BOFs, and enjoy the rest of your conference, and hopefully you'll be able to make it to some of the sprints. It should be exciting.